All right, so we started last time talking about formal proofs, and that they were basically ways of doing proofs where we didn't have to use truth tables because they get kind of tedious to do, and we want to be more intelligent about how we're actually writing a proof. So let me, actually I had a reason for pulling this up. I wanted to work one of the problems that were on there. So I often, as a little cheat code for you guys, I often work things in class that are on your assignments. So if you hadn't noticed that yet, make sure you take notes because they're often exactly what you have to do on homework. So I'm going to work one of the problems that's on the proofs tutorial. Am I going to tell you what number it is? No. Okay. Actually, it's number 1. Just kidding. Okay, it's going to be, our first given is going to be A implies B. Then we're going to have C implies D. And we'll have not the quantity. A implies D. And we need to prove B and not C. Okay, you guys know that I'm lazy, right? So you can do this. It's totally fine for you to write given and just say all these things are given. We're trying to prove B and not C. Oh, sorry. Sorry about that. There it is. Okay, so today we're going to talk about proof by contradiction first. So a proof by contradiction is when I assume my givens, and then I assume the negation of the conclusion, and then I derive a contradiction. And that probably doesn't make any sense to you, so we're just going to do it, and then we'll talk about it some more. So, what does that mean? Negation of the conclusion means take the conclusion, copy it down, and then put a not in front of it. Now, you should be really excited because this is the only time you could randomly negate something. I know you're super excited about that. That's right. Good. Thank you. Okay. Now, I'm pointing this out and trying to make it funny because I don't want you to randomly put nots in front of anything. This is the only time you can do it, is when you write the word negation of conclusion. It means I am negating the conclusion. If you have anything else that you're putting in your proof, and you put, it's true, it's in the givens, and you put a not in front of it, then you've just put something false into your lovely mix of true things. And you're going to mess it up. So what we're going to do with a proof by contradiction is, how many of you have seen magic card tricks? Okay, so most everybody's seen them, and a lot of them have to do with red cards versus black cards, right? And almost all the time, the tricks have to do with the person who's dealing with the cards has already prearranged them. So half of them are one color over here and half are one color over here, and they already know something about it, and they're showing you things and making it look like, they have magic powers. Okay? Well, the magic power here is I'm going to start out, when I do a proof, everything in it I'm claiming is true. Okay? And that's why a direct proof, when I get to the bottom, when it has written on that line the thing I want to prove, then I'm happy because it's on my true list. Okay? Now, if I believe that I can prove this statement, then I believe it is true, right? So what should this statement be? It should be false. All right? So think about this as a deck of cards. These guys are red, okay? And this one's black because it's false. Now what I have to do is I'm going to shuffle my deck until I show that there's something black in there. And the only black thing that could be in there is this, because it's the only thing I've negated that I think should be true. So that's really how a proof by contradiction works, is that I have some true stuff, I throw the opposite of what I want to prove in there, shuffle it around until I show that something in there has to be wrong, and it has to be the thing I threw in. Okay? Now I posted an example of this on Piazza, okay? And hopefully it'll be a real example for you guys. How many people have ever had anybody give you any money to help with your school? Okay, excellent. Most people. So this example should be real for you. All right? Suppose this person gave you some money to help you with school. but they were maybe worried that you're going away and you've never been away from home before and you're going to spend all your money on beer or some other such thing that you shouldn't be spending your money on, like a car or whatever. And they want to be sure that you're actually spending your money on your education. So a direct proof that you are spending your money on your education would be what? A receipt, right? Or they can pay directly for your bills, right? You could give them receipts for your books, receipts for your food, for your housing, for your tuition, all that stuff. Okay, do you want to do that? No, it sucks, right? Receipts are terrible. I hate them. Okay? They're like, tax forms and stuff. It's not good. Okay? So what do you normally do? You call Grandma and you say, Grandma, I got all A's. I couldn't have possibly spent my money on beer. Right? That's what we would call an indirect proof, okay? The indirect proof is, if I get the cash and if I were to spend it, suppose I did spend it all on beer, would it be possible for me to make all A's at my challenging engineering major? The claim is no. Okay? So you want to make the case that there's a contradiction here. I couldn't possibly have spent all the money on beer and also get all A's at the same time, so therefore I must not have spent all the money on the beer because I have the A's and here's my report card. Okay, so, maybe you guys have already figured out the financials and you can buy plenty of beer and also make A's. Good for you, but I'm going to assume that you can't do that. Okay? And maybe you think you can do that because you haven't turned any homework in for this class yet. So next week you can't do it. Okay? So, we do it all the time. We do proof by contradiction all the time. Right? Whenever anybody accuses you of not doing something, you're like, I did it, here's some evidence. But it's usually a proof by contradiction. So watch yourself for a week and see if you use any proofs by contradiction. So proof by contradiction is where you say, well, if I did that, then it would have been this way, but it's not. So that's a contradiction, so I didn't do that thing. Okay, we do it all the time. So how we literally do it with our with proofs for computers is we write down the opposite of what we're trying to prove. We end it with all the stuff that we know is true because it's a hypothesis, and then we're going to try to combine it. So what I like to do is mark the negation of the conclusion with the dollar sign. And now you're probably like, wow, what are you doing there? So remember I told you this is like I have a deck of cards. Some of them are red. This one is black. I want to show that it's black. Okay? The way I'm going to show that it's black is I'm going to recombine them all until I get a contradiction. So I have to get something false. So I have to actually literally get something that means 0, like P and not P. Or A implies B and not the quantity A implies B. That's definitely false, right? Can't argue with that. Those are contradictions. Anything ANDed with its opposite is a contradiction. That's rule number 26. So if you see rule 26 all over your homework, that's what it's talking about, is that if you have two things ANDed together that are opposites, we always get 0. That's what that means. So I'm labeling this with money because if I want to get the black card out, I have to use the black card, right? So if I have a deck and all I'm doing is playing with the red cards, am I ever going to pull a black card out? No. This is the black card. So I have to mix it with the red ones in order to get the money out. So I like to call this the money because this is like the store. I'm going to spend my money at the store to get my black card. All right, how am I going to do it? Well, first I have to get rid of this knot on the outside. And we talked about De Morgan's last time. That helps us distribute knots across ands and ors. So let's do that. So we should get not B and not C if I don't skip any rules. And that's from line 4 and De Morgan's. And I'm going to cross this out because I've used it. It doesn't mean I can never use it again, but just to help me pay attention to where I am, I'm going to cross it out. And if I derive it using the negation of the conclusion, I'm going to put a dollar sign next to it, just so I know I'm keeping track of the fact that I'm going to use something that came from the negation of the conclusion. You look like you have a question. You're right. Thank you for checking my mistake. So we had B and not C, and then when we negated it, we should have not B or not C. Good checking. Okay. Now we're going to get rid of that double negation. So we have not B or C from line 5 and double negation. And these are still from the negation and the conclusion, so I'm going to keep labeling it like it's money. Now, does anybody know what not B or C is logically equivalent to? B implies C, good. So that is from line 6 and the implication rule. All right, so now we've actually sort of applied De Morgan's and we've gotten rid of as many symbols as we can with this, right? There's nothing else I can do to this by itself without starting to combine it with something. So now I need to go to the store, which is my givens. And I want to see if I can combine this B implies C with something. And I'm going to keep doing that repeatedly until I find two things that are opposites. So I got to be watching out all the time for two things that are opposites. Did you have a question? Okay, any questions so far before I slide this up? Yes.
Are the givens always consistent?
Are the givens always consistent? I will never give you a problem when the givens are false. Is that what you're asking? Yeah, so we won't, so what we're practicing in this class is how to prove things that we know we can prove, or at least we think we can prove. So I'm not going to give you something that shouldn't, that if I ended those two things together, I'd get a contradiction. So I don't have any problems like that. It's possible for you to run into those problems. If you did, then I would work the problem again and make sure, and then you won't run into it in this class, but if you ran into it somewhere, if you feel free to bring it to my office and I'll check it for you. Okay, so what do you think we could get? So what's the first thing you see? If I combine B implies C with something, what can I buy at the store? I can get A implies C. So this is still somehow derived from my negation of the conclusion. So that was from line 1 and 7. And hypothetical syllogism, remember that was the transitive rule, like less than or equal to has. Now we're going to repeat that process. So we have our A implies C money. We need to see what we can buy. We've actually kind of already used A implies B, so I'm going to put a check next to it. Again, you can reuse a line. I'm just marking which ones I've used just because I want to use the other ones first. If I've already used it, I want to try the other ones that I haven't used first. So now I think we can actually use the same rule with line 2, right, and get A implies D. So we've used line 2, used line 8. This is still coming from the negation of the conclusion. Does anybody think we're almost done? Raise your hand if you think we're almost done. Good. And most of you see that we're almost done. So what is the line that shows us that we're done? So 3 and 9 are what? They are opposites. So now all we have to do, so this is a funny, weird thing that we have to do. We have to put them next to each other. So it's easy to see that they're opposites. So that's the next thing we absolutely have to do. We have to say the quantity A implies D and not the quantity A implies D. And that's from lines 3 and 9. And the rule is called conjunction. And it's weird to have a rule for this, but basically we have it because everything in a proof is anded together, but we usually keep them on separate lines. So if we put them together, we say conjunction. So if I know two separate things are true in two separate places, it's like my friend over here told me that this car was red, and my friend over here told me that it was a Porsche. I put them together, I get red Porsche. There's a rule for putting those two things together from two different sources. So that's what conjunction is. It's the funny Latin word for and. Have you ever heard of the conjunction junction from the... Yeah, exactly. That's what it's from. Yes? Yes, you will always do a conjunction, and then you'll do one more thing, which is to claim that there's a contradiction. So that's the last thing that we're going to do. We're going to have another line that says contradiction. And on your homeworks, it actually says Rule 26, but you don't have to write it on your homeworks. Like if you handwrite something on the test, you don't have to put Rule 26, yes.
In our web assignments, when it asks for the rules we use, do we say like Rule 27, or do we say...
Just type the word. Type the word. I don't think I put the table of numbers in there. But if you use my abbreviations like HS and DN and DM, so my abbreviation actually is DM in the system and IMP. So all these you could type just like that. Yes, you can type the whole word, or you can type an abbreviation like a 2-letter abbreviation or 3.
So all of the rules that you have on the right, those are all the NIC rules?
Yes, these are all on the axiom list. So hypothetical syllogism is in the first 10, and the first 10 are all logical implications that only go one way, and the rest of them are equivalences, like things I can substitute anytime I want to. So double negation and De Morgan's are logical equivalences, right? So I can go back and forth in between. But once I've derived, like say on here, I've derived A implies C from A implies B and B implies C, I can't go backwards. So just because I know A implies C doesn't mean I can know the other stuff. So when I'm working a proof, I can go forwards, but I usually can't like look at something here and then derive something that came earlier. So I can look at the list and see what it is, but I can't derive new stuff from it.
So basically, the way that this works on the larger scale is that you take your proof and you negate it, and then you say, if the proof was true, I've now made it false, and then you prove that it's false.
Right.
By finding the.
That's right. Yeah. So what's your name? Ben was just clarifying that the process we've just gone through is when we're trying to prove something, this is called our conclusion. So when we did the proof, we assume this is false, right? And we stick it in, well, yeah, we assume it's false. We stick it in here, and then basically when we get to the bottom and we show that there's a false, the conclusion naturally is that the thing we stuck in there must be false, right? But if I put another not in front of this, I get back the conclusion, right? So if line 4 is false, then B and not C is true. So we don't have, when we do a proof by contradiction, since we put in the negation of the conclusion and we get a contradiction, the assumption after that, like I don't have to write a sentence that says, because I have a contradiction, the negation of the conclusion is false, so therefore the conclusion must be true. That's what it means, but I don't have to write that down because everyone who reads these kind of proofs knows that that's how they work. So once you have a contradiction, you're done. Yes? Yes, you will have to do 4 through 11 on your own. That is exactly why I tell you to print out the homeworks and do them before you go to WebAssign, because WebAssign has some print in the, fill in the blanks. But that is also the reason why we have the labs, the deep thought, justified thought, deep thought, and the proofs tutorial, because those are ways where you get to work the problem, like 4 through 11 on your own, but the computer's checking it for you. Because otherwise, if you had all those papers and turned them in, it would take us forever to read them all and get it back to you. And so that's why we're trying to give you different tools for giving you the feedback on different ways to do it. So WebAssign is a quick way to get feedback, but it's not very smart. The other ones are smarter, but they require a little bit more work on your part to enter the answers. So the reason why you have these fill-in-the-blank proofs on WebAssign is just to get an idea of like what a proof looks like and what the rules, individually do. So it's practice. So if you need more proof problem practice, do the ones that are on the proofs tutorial. Take the ones that are even on WebAssign and like erase cover part of it and see if you can do it. You'll be amazed that your brain will totally forget like what you just did, and you can use that same problem again. Or if you're doing a direct proof, you can do it by contradiction. Or vice versa. If you have a proof by contradiction somewhere, you can do it by direct proof as a practice.